Welcome to our first notes video of brand new content for 8th grade. Other notes videos we've seen so far this year have been review skills, have been just like typical reminders on how to do things, have been going over homework, but this is our first video of new content that you're going to put into your notebooks to help you with your next assignment. Throughout the course of this video, you're going to see symbols throughout. You're going to see a stop sign. If you need a stop sign and you see it there, it might just be best to pause the video at that point just to finish writing down whatever is there or to try a problem. You might see a listen on those. That's just making sure that you're hearing what's going on there. If you only hear a listen or you only see a listen on any kind of part of this video, you don't need to write anything down. You don't need to stop. You don't need to do anything else. It's just kind of hearing what's next. And then you're also going to see this symbol every once in a while. Once you see this, I'm expecting that you write down the things that I'm either writing down or highlighting throughout the video. So we're going to get started in a notebook piece of paper. In your notebook, if you could write down notes, and then our title of our notes is Product of Powers. Also throw today's date, 9/17, on there. And then by the end of your notes, or before we actually start, I should say, by the time you've written, it should look like this. So notes 9/17, power of products. You see our symbols up here to listen and to write down. If you need to stop, stop, and then continue as we continue into our video. So I'm going to recap, and this is just a listen section really quick. This was our assignment that we had yesterday, and this was from our Desmos activity, and this was the circles. A couple things I want to point out on some patterns that I'm hoping you saw. I'm going to start in Kieran's column, and we see some different things happening there with some multiplicative ideas. So I know that 2 times 4 equals 8. So I'm just going to write that down. I know that as I continue and I start to look at other things, because I'm going to look at these patterns and continue, I know that also that 2 times 8 is 16. And if I'm looking at other patterns, I can see that, let's look at one more, that 4 times 8 is 32. So if we look at those things, I'm going to start to use a different color, and we're going to start to connect some other ideas based off of those pieces of information. So I'm just going to draw a line like that. So if I'm looking now at Jada's column, I'm going to see that same thing. So when we said 2 times 4, so Jada's equivalency was still 2, and then times 4 for Kieran was the same as 2 times 2. So hers was 2 times 2 times 2 was equal to 8, according to Jada. So we have the same thing being said in these two sections. If I go to that next one, in Kieran's, it said that 2 times 8 was 16, so 2 times 8 was 16. In Jada's, we're going to use those same columns, but instead of 2 here, we're going to represent with this 2. And then we're going to, instead of writing 8, we're going to write out the expanded form, 2 times 2 times 2. So now I have 3 2's being written down. And then what we still said is that this should equal 16, and we see it straight across right here. I have 4 2's written down. 4 2's is equal to 16. So we have equivalency there. The last one that we were looking at was 4 times 8 to equal 32. So again, I know I'm getting messy with my circles, but 4 times 8 to equal 32. Let's look at the equivalencies there. 4 was the same as 2 times 2. 8 was the same as 3 2's, or 2 times 2 times 2. If I multiply all those together, I equal 32. And what Jada should have written here was 5 2's all in a row, and that's what we have. 5 2's all in a row, and that equals 32. So now the connection is that rather than writing all of these 2's down, it's going to be much easier if we start getting this idea about power of products. So I'm going to really quick just kind of justify what Noah is doing to get these exact same answers, 8, 16, 32 for these same columns. So let me get rid of all these circles up here because I know that's getting a little bit confusing, but now let's look at just Noah's in a simplified version. So in Noah's, we can use those same things. I'm looking at stage 1 being multiplied by stage 2, and that's going to equal the values in stage 3, because we had stage 1 was 2 times 4 in stage 2 equals the value in stage 3, 8. So if I'm looking at Noah's, that to me says 2 to the first times 2 to the second should equal 2 to the third, and 2 to the third is 8, and we know that that first column should equal 8. We know in our next one that we're looking at 2 and 8 here in the number of circles, so let's circle those again. 2 and 8, so 2 times 8, excuse me, is equal to 16. We proved that in Jada's column because we had now 4 2's being multiplied together, because we had 1 and then 3 more being there. In Noah's, we're going to put those same things together. Stage 1 was 2 to the first, stage being multiplied by stage 3, which was 2 to the third, is equal to 16, which was 2 to the 4th. And that's not 24. I'm going to make that a little bit smaller, 2 to the 4th. And we knew 2 to the 4th, according to Noah and stage 4, is the same number of circles as 16. The last one we can connect here to get to our power of powers is this idea of, let me just get some of these erased so we can get a little bit more clear, is we had 4 times 8 being equal to 32. So 4 circles times 8 circles was equal to 32 circles. We look at the stages, that means that the values of circles in stage 2 times the circles in stage 3 should equal stage 5. And so we can see if we can prove that through Noah's idea. So we have 2 to the 2nd being multiplied by 2 to the 3rd. And if I take those values, 4 times 8 is 32, I should equal 2 to the 5th. And 2 to the 5th does equal 32. So the focus of our video is going to be in this section right here, is writing out all the same values. Because you look at everything else in this top column, every answer was equal to 8. If you look at every answer in this column, everything was equal to 16. Everything here was equal to 32. This just dealt with circles. This dealt with expanded form representation of those circles. And this dealt with the exponential. Exponential is nice because you don't have to write out so many 2's. Circles, you don't have to rely on solving all those 2's. You can just keep them in exponential form. And now we're going to start to see some shortcuts. We're going to start to see some things that we have here, and I'm really going to look at our answers here in exponential form. So we're going to go and justify some things, and I'm going to look at one other example before we continue. And that example is from your assignment yesterday. Again, we're still listening at this point, nothing to write down. Your assignment here, or the question was, who's correct? Is it Tyler or is it Lynn? Lynn said that in stage 23, there's going to be 8 times as many circles as stage 20. Well, if we had stage 20, and then we went to stage 23, there's stage 21 in between and stage 22 in between. To get from 20 to 21, we multiplied the circles by 2. To get from 21 to 22, we multiplied the circles by 2. To get from stage 22 to 23, we multiplied the circles by 2. So if we combine all of those, 2 times 2 times 2, to get from stage 20 to 23 should be a times 8. Another way to say 2 times 2 times 2, or to say 8, is 2 to the 3rd power, because we have 3 2's being written together, multiplications in the middle, 2 to the 3rd power, and that's equal to 8. And that's going to justify why Lynn is correct and kind of show some information as to what we're doing here. So now, what I'm going to have you write down first is I'm going to highlight some stuff here, and this is going to be your first thing that you're going to stop and write down into your notes. So on that notebook document, you have your title, you have power of powers, or excuse me, product of powers up here, and then you're going to have a definition. So your definition is to multiply powers with the same base, you're going to add your exponents, and we'll justify that, and we'll talk about what that means. So I'm just going to have you write down those highlighted sections. Then on the next page, or on the next slide, I'm going to show you a sample. So if I'm going too fast, stop, and then just make sure you have that down, hit play again, and I'll continue on to the next sample. But I'm going to write down this and not have, and go kind of step by step, and you're going to kind of follow along with me. So at this section, you're going to stop and you're going to write down as I'm writing things down. And if you can format them the way that I do, I think it'll make a little bit more sense as to what we mean when we say add the exponents. So our example problem that you're putting in your notes is right from the book. We're going to put 3 to the 2nd power times 3 to the 4th power. And we have them in exponent value. Rather than solving 3 to the 2nd, 3 to the 4th, and then multiplying together, we have a shortcut where we can keep everything in exponential value, and now we can talk about huge numbers in many different ways. So in order to understand this the absolute best, I'm going to write it down in expanded form really quick. 3 to the 2nd is 3 to the 3rd, or excuse me, 3 times 3. I bring down my multiplication sign. And then 3 to the 4th in expanded form is 1, 2, 3, 4 3's with multiplication signs in the middle. So we just broke down the problem into 3 sections. So now as I look at what's happening there, if I look at this line right here, I'm going to record and I'm going to say, well, hey, I have this multiplication sign in the middle. That's 6 3's, and if you could jot this down, all being multiplied together. 6 3's being multiplied together is equal to 3 to the 6th. So we know that. So now our shortcut and our rule, and again, I'm going to zoom out a little bit, so if you need to see this a little bit more, stop and just make sure you get all this into your notes, but I'm going to zoom so I can write a little bit more. So then the shortcut would be we go back to the original problem. The original problem was 3 squared, or 3 to the 2nd power, times 3 to the 4th. And then now to end up, we know the answer is 3 to the 6th. The shortcut is that when we had the same bases, 3, I can just add the exponents. So 4 plus 2 got me 6, and that was my shortcut. And so we kind of proved why that works because we have our expanded form right there. 3 times 3 times 3 times 3 times 3 times 3 was equal to 6 3s. So now we could kind of justify in this version why we're getting that answer, or why we're able to add our exponents. So I'm going to keep moving forward, stop, record, make sure you get this into your notes. At this point, your notes should look like this as we had them taken care of. So if you need to, make sure you stop and get these taken care of. And then the last thing we're going to take a look at really quick is looking at 3 very quick problems. If you want to see me solve A and B and want me to slow down a little bit, then we can go back and check out some of those examples, or you're going to go to your page in your math book and you're going to look at page 24 and you're going to look at some of those purple tutor, and my drawing's going to be terrible, but you have those tutor buttons in purple. Those are all clickables. Those are all kind of walkables through different examples too. So what we can look at here is I'm just going to use my shortcuts now to solve. So I have same bases of 9, so it's 9 to the third times 9 to the second. I'm going to add my exponents, 3 plus 2, 9 to the fifth. In letter B, I have A and I have A, same bases, great. I'm multiplying them. That means the shortcut in exponential form is add the exponents, A to the fifth. And then lastly, in C, we're seeing a different connection of things. So you can just keep listening. Otherwise, if you want to put this example in your notes, that's great too. But I'm just going to write it a little bit larger. That's a terrible color for this background. We have -2 times m being multiplied by -8, which is being multiplied by m to the fifth. So we have kind of a messy example here, but what I'm going to rewrite it as is just one gigantic multiplication chain, because for me, that makes a little bit more sense as to what we're looking at. So here, I know I can't multiply -2 and m together because we don't know what m stands for. But what I can do is I can multiply m and m to the fifth together. And that is the same as, I'm just going to rewrite this down here, 1 times 1, 2, 3, 4, 5 m's. Because I have 5 m's there being multiplied by 1 m there, and I'm connecting that there to equal m to the sixth. Because now I just have 6 m's being multiplied together. So really we were seeing almost like an invisible 1 as our exponent, and then just adding those exponents together. So m to the sixth. Then I still have to add my other bases. Since I can't multiply them. Since I can't multiply these by any m's because they have different bases, I can multiply numbers together. -2 times -8 is positive 16. And so now my final answer, and I can't go further, is 16 m to the sixth, because I'm still multiplying those two together from the original problem. So now I'm just kind of condensing things into an exponential form to get to my next step. So 16 times m to the sixth, or 16m to the sixth. So hopefully this video helps understand some different things as we go. You have tutor videos in your book, and you have some examples as you kind of walk through those as well. So product of powers, our shortcut is when bases are the same, add the exponents.